let's say I have a matrix where everything below the main diagonal is a 0. And I'll start, just for the sake of argument, let's start with a 2 by 2 matrix. So let's start with a 2 by 2 matrix. So I have the values A, B, 0, and D. So instead of a C, I have a 0 there. So everything below the main diagonal is a 0. So what is the determinant of this going to be? Let's call that matrix A. So the determinant of A is going to be equal to AD minus B times 0. So that's just 0, so we don't have to write it. So it's equal to A times D. Now let's say I have another matrix. Let's call it B. And let's say it's a 3 by 3 matrix. It's a 3 by 3 matrix. And let's say its entries are A, B, C. You got a 0 here. Then let's say you have a D here, E. Then you have another 0 here, another 0 here, and you have an F. So once again, all of the entries below the main diagonal are 0. What's this guy's determinant? Well, we learned several videos ago that you can always pick the row in the column that has the most zeros on it. That simplifies your situation. So let's find the determinant along this column right here. So the determinant of B is going to be equal to A times the submatrix if you were to ignore A's row and column. So A times the determinant of DE0F, and then minus 0 times its submatrix, so you cancel out, or times the determinant of its submatrix, that row and that column, you get BC0F, and then you have plus 0 times, you get rid of that row, that column, you get BCDE. Now, obviously, these two guys are going to be 0. I don't care what these 2 by 2 matrices, what their determinants end up evaluating to. So these are both going to be equal 0 because we're multiplying by 0. But we're left with A times the determinant of this. And the determinant of this is pretty straightforward. We're going to have, it's going to be equal to A times, the determinant of this is DF minus 0 times E. So it's just going to be DF. So it's going to be DF. So the determinant of B is ADF. Notice the determinant of A was just A and D. Now, you might see a pattern. In both cases, we had zeros below the main diagonal, right? This was the main diagonal right here. And when we took the determinants of the matrix, the determinant just ended up being, the product of the entries along the main diagonal. And if you think that that's a general trend that always applies, you are correct. We can do it in the general case. Let's do the general case. So let's say we have some matrix A, and it is equal to A11, and you have A22. You're going to have a 0 right there. And then you just keep going all the way down to ANN. In this row, everything is going to be a 0. Everything's going to be a 0 except for that last column. This is all a 0 right here. So everything below the main diagonal is a 0. Just like this one, but we're doing it in the general n by n case. And everything up here is, well, it doesn't have to be 0. This is A12 all the way to A1n. This is A2n. Keep going down. So everything at the main diagonal or above isn't necessarily equal to 0. So if you wanted to find the determinant of A, we can do the same thing we did here. We could go down that first row right there. So the determinant of our matrix A is equal to this guy, A11, times the determinant of its submatrix. So that's going to be A22, goes all the way to A2n, and then A33 all the way to ANN, all the way to ANN, and then everything down here is, these are all zeros. These are all zeros. So once again, we have another situation where all of the entries below the main diagonal are 0. So what's the determinant of this guy right here? And look, you might say, hey, what about the rest of that row? Well, the rest of the row is just a bunch of zeros, just like we had here. It's 0 times the determinant of its submatrix, and then that'd be a minus and a plus, 0 times the determinant of its submatrix, so on and so forth. So we just have to pay attention to this term right there. Now, the same argument we can do here. To find this determinant, we can just go down that row. So the determinant of this is just going to be equal to, let's write out, let's not forget our A11 out there. A11, and then the determinant of this is going to be A22 times the determinant of its submatrix. Get rid of its row and its column, and you're just left with A33 all the way down to ANN. Everything up here is non-zero. This is A3N. And then everything below the diagonal, once again, is just a bunch of zeros. Everything down here is a bunch of zeros. Another what we call upper triangular matrix. Let me write that down. This whole class where you have zeros below the main diagonal, these are called upper triangular matrices. Triangular matrices. Matrices, just like that. Now, we keep doing the process over and over again. If you just keep following this pattern over again, now you're going to have the determinant of this is A33 times its submatrix, and every time the submatrix is getting smaller and smaller, you will eventually get to A11 times A22 times all the way to A n minus 2 times a 2 by 2 matrix over here. Times a 2 by 2 matrix here. That's just going to be a n minus 1, a n sub n. This is going to be a sub n minus 1, n. And then you're going to have a 0 right here. So it's just the bottom right-hand corner of our original matrix is what you're going to be left with. And what is the determinant of this? Well, it's just the product of these two things. It's just this guy times this guy minus this guy times that guy, but that's just 0. So the determinant of A ends up becoming A11 times A22 all the way to ANN, or the product of all of the entries of the main diagonal, which is a super important takeaway because it really simplifies finding the determinants of what would otherwise be really hard matrices to find the determinants of. You could imagine if this was, a 100 by 100 matrix. Now we can just multiply the diagonal. So just to make sure that things are clear, let me do an example. Let's say we find the determinant of 7, 3, 4, 2. Yes, so we have zeros here. Let's say it's a minus 2, 1, and a 3. We have a 0 here. Sorry, we don't want zeros there. We don't need to have zeros there. 6, 7. We actually could have zeros there, but we don't need to have zeros there. You have a 0 there, and you have zeros there. Just like that. So it's upper triangular matrix. If you want to evaluate this determinant, you just multiply these entries right here. So the determinant is equal to 7 times minus 2 times 1 times 3. So it's 7 times minus 6, which is equal to minus 42. And it's that easy.